Let's talk about pH. So yesterday we did a lab where we saw that by using a special dye, we can identify the pH because it changed colors. So here you see an example of that, right? Now I know what you're thinking. This is 0 to 14. Depending on what textbook you look at, it's 0 to 14 or 1 to 14. I like to use 1 to 14, so I'm just going to go ahead and eliminate this guy here. But what we learned was that if we have somebody who's way down here, for example, that's probably acidic, pH 1. And if it's way over here, it's probably basic, pH 14. So 1 is a strong acid, 14 is a strong base, and 7 in the middle, that's neutral. That's kind of where we expect water to be. Okay, now, what does pH actually mean? So it means the measure of the amount of hydrogen in a solution. And we wrote this down the other day. So let's write a few equations here to make sense of it. So the first equation I'd like you to write down is this one right here. Let's get a nice color for you. How about blue? So let's write this one. If you have an H inside brackets, that's kind of chemistry shorthand for the concentration of hydrogen. So if it has a lot of hydrogen, it's an acid. Going to be a low pH. We could also do it the other way. Let's write this equation. In brackets here, OH, now that's the concentration of hydroxide. So remember, hydroxide tells us it's a base, and hydrogen tells us it's an acid. Okay, let's take a look. Now here's a table. You're all going to get this table in just a little bit, so you don't have to copy this down. But this tells you how to go back and forth from the concentration of hydrogen to the pH. And it's really, really simple. And if you don't even know how to do it, you can just look at this table and go back and forth. For example, if I had something which is 0.0001 concentration of hydrogen, I'd say, okay, that's pH 4. So all you got to do is find the concentration of hydrogen, and it tells you the pH. But let me just show you how to do it if you didn't have this table. So let's go ahead and write down this one here. Here's an example. Suppose the hydrogen concentration is 0.001, right? What is that? Well, if you go ahead and look at it in scientific notation, we have 1, 2, 3, 4. So it's 10 to the negative 4. Now sometimes it's actually written like this. This E is the same thing, E to the negative 4. It's just how calculators tend to do things. 4, what does that 4 mean? Means it must be pH 4. Okay? So concentration equals pH. Let's write that down. And here's our example. If it was 0.0001, 1, 2, 3, 4, it must have been pH 4. Let's take a look at that table again there. There's 0.00001, 1, 2, 3, 4, 10 to the negative 4, or E to the negative 4, pH 4. Let's go ahead and try one. Let's just do an example here. What if I told you, for example, that, the concentration of hydrogen, sorry about my lousy handwriting here, the concentration of hydrogen is 10 to the negative 6. Let's see, 10 to the negative 6, there it is. I could have written it as 0.000001, but 10 to the negative 6, oh, that's too easy. It must be pH 6. What have I told you? Let's cross this out. It was 10 to the negative 9. Hey, I don't even need to look at that table. That's got to be pH 9. So it's really easy to go back and forth from the concentration of hydrogen to the pH. And all you have to do is use this table here. Now you may have noticed, what's this over there? pOH, pOH. Well, it turns out you can do exactly the same thing with pOH, right? So the concentration of hydroxide is pOH. So let's take a look here. Let's try another one. Suppose I told you now that I'm going to measure the concentration of hydroxide. So what have I said? The amount of hydroxide in a base, right, was 10 to the negative 3. No problem. The P, not H, but the concentration pOH would be 3. Really simple, huh? Okay. How can we bring these two together? The magic number is 14. The concentration of hydrogen plus the concentration of hydroxide equals 14. Too complicated? Let's try it. What if I told you that the pH is 4? What would be the pOH? Would be 10. 4 plus 10 is 14. How easy is that? Hey, let's bring it all together here. How about water? Now, I know you guys always were brought up to think of water as H2O. But really, it's HOH. It's a combination of hydrogen and hydroxide. And we know that at water, hydrogen and hydroxide are equal. So if two numbers are equal and they have to equal 14, they must be 7 and 7. And so the pH of water must be 7. Da, 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 da. Let's try a couple more problems and then I'll let you do the worksheet. All right? How about this one? If a base is pOH equals 9, so the concentration of hydroxide is 9, what is the molarity of hydroxide? Wow, this is just too easy, right? Let's try it. 9, 9, 9. So what must be the concentration of hydroxide? 10 to the negative 9. That's too easy, right? Now suppose I wanted to confirm that. Well, let's do it this way. pOH and pH have to add up to 14, right? So if that's 9, the pH must be 5. Let's take a look. pH 5, where was it? Let's see, pH 5, there it is right there. Yeah, so the pOH, if this is 5, must have been 9. That's too easy. Let's do one more, and then we'll try the worksheet. How about this one? What is the pOH if an acid is pH 3? Oh, this is too easy. They have to add up to 14, right? If pH is 3, then pOH must be 11. And that's how you do it. Now I'm going to give you a worksheet where you're going to have this table right here. And we're going to go ahead and cut this out and put in our notes. But this guy tells you how to go back and forth between the concentration of hydrogen and the pH of the solution.